I want to tell you about something that bothered me for years. Still bothers me, actually. You're going to think I'm being difficult, but I'm not. I'm being honest. And that honesty led me to call nature absurd. Not broken, not confusing, absurd. Let me start with something simple. You take an electron, tiny thing, fundamental particle. You fire it at a wall with two slits cut into it. Behind that wall, you put a detector screen. Now, what happens? You're probably thinking the electron goes through one slit or the other. Makes sense. It's a particle. Particles go through one place at a time. They follow paths. They have positions. That's what particles do. Run the experiment. Fire one electron. It hits the screen. Mark appears. Fire another. Another mark. Keep going. Fire 100, 1,000, 10,000 electrons, one at a time. Each one makes a single mark on the screen when it arrives. But here's what destroys everything you think you know about reality. Those marks don't appear randomly. They form a pattern, an interference pattern, bands of high density alternating with bands of nothing, the exact pattern you'd get if you sent waves through both slits and let them interfere with each other. Waves do this, water waves, sound waves. When two waves overlap, they add up in some places and cancel out in others. That's interference. But we're not sending waves. We're firing individual electrons, one at a time. Each electron makes one dot. Yet somehow, collectively, they create a wave pattern. Stop and think about what this means. Each electron apparently goes through both slits simultaneously. It interferes with itself. A single particle taking two paths at once. Not because we're confused about which path it took. Not because we lack information. The electron genuinely does not have a definite path until we measure it. You don't believe me. I wouldn't believe me either. So let's check. Put detectors at the slits. Watch which slit each electron passes through. Now we'll know what's really happening. You run the experiment again with detectors active. Fire electrons one at a time. The detectors work perfectly. Each one tells you which slit the electron went through, left or right, never both, never neither, always one or the other. Good. Particles behaving like particles. But look at the screen. The interference pattern is gone, completely gone. Now you just get two bright bands behind the two slits. Exactly what you'd expect if electrons were simply particles going through one slit or the other. No interference, no wave behavior, nothing weird. Take the detectors away. The interference pattern comes back. Put them back. Pattern disappears. It's not that the detectors are physically blocking something. It's not that they're bumping the electrons off course. The mere act of determining which slit the electron passes through destroys the interference pattern. The electron knows whether you're watching. Not watching in some mystical conscious sense. I mean, the universe knows whether the information about the electron's path exists. If that information exists, no interference. If it doesn't exist, interference appears. Every single time. No exceptions. Thousands of experiments. Always the same result. This violates everything your brain tells you should be possible. An object should be in one place at a time. It should follow a path. Measuring where it is shouldn't fundamentally change what it's doing. These seem like reasonable expectations. Nature disagrees. I developed quantum electrodynamics. Won a Nobel Prize for it. The theory predicts experimental results to 10 decimal places. It's the most precisely tested theory in physics. I can calculate anything you want about how electrons and photons interact. I can give you numbers that match reality. So exactly it's almost disturbing. But I cannot tell you what the electron is actually doing between emission and detection. I cannot give you a picture of its path. I cannot explain it in terms of anything you've ever seen before, because it doesn't behave like anything you've ever seen before. When I say electrons behave like particles, I give the wrong impression. When I say they behave like waves, that's also wrong. They behave in their own way, a quantum mechanical way. And that way is fundamentally, irreducibly different from everyday experience. People kept asking me to explain it, make it intuitive. Give an analogy. Compare it to something familiar. I couldn't do it. Not because I'm bad at explaining things. I spent my career teaching physics. I love making things clear. But you cannot make this clear using familiar concepts because there are no familiar concepts that work. That's what I meant by absurd. Not that quantum mechanics is wrong. Not that the experiments are flawed. Not that we're missing something. The theory works perfectly. Nature actually behaves this way. That's what makes it absurd. Reality itself, at its most fundamental level, operates according to rules that make no sense to creatures like us, who evolved to throw rocks and pick fruit. And the strangest part, this isn't some edge case or rare phenomenon. This is how everything works. Every atom in your body, every photon hitting your eye, the entire foundation of chemistry, electronics, modern technology, all of it resting on behavior that defies comprehension. But wait, I told you the double-slit experiment. I told you electrons create interference patterns. I haven't told you what that actually means for reality itself. Let me show you what I mean by asking a question. Where is the electron before you measure it? You want to say it's going through one slit or the other. You just don't know which one until you check. That's how normal objects work. A ball goes through one hole or another hole. Your ignorance about which one doesn't change the ball's actual path. The ball went where it went. You just didn't see it. But that's not what happens with electrons. The electron doesn't go through one slit while you're ignorant about which one. It's not that the electron has a definite path and you simply lack information. The electron genuinely doesn't have a path. It exists in what we call superposition, a state where it's simultaneously taking both routes, not both in the sense of splitting in half, not both in the sense of going back and forth really fast, both at the same time, in a way that has no classical equivalent whatsoever. This isn't philosophy. This is measurable. The interference pattern proves it. Those alternating bright and dark bands on the screen exist because the electron interferes with itself. The version going through one slit affects the version going through the other slit. They're not separate. They're the same electron existing in multiple states simultaneously until measurement forces it to choose. And here's what really disturbs people. The electron doesn't just fail to have a definite position. It fails to have definite properties at all until measured. Spin, momentum, energy state, all of it undefined. Not unknown, undefined. There's a difference. Unknown means the value exists, but you don't know it. Undefined means the value literally doesn't exist yet. Heisenberg figured out something profound about this back in 1927. He realized you cannot simultaneously know both where something is and where it's going with perfect precision. This has nothing to do with measurement technology. It's not that our detectors aren't good enough. It's that the universe itself doesn't allow the information to exist. The more precisely you pin down position, the less defined momentum becomes. The more you nail down momentum, the fuzzier position gets. The product of these uncertainties has a minimum value. Planck's constant divided by 4pi. That's the floor. You cannot go below it, even in principle. People thought this was about disturbance, like shining light on an electron to see where it is bumps the electron unpredictably. Wrong. That's not what's happening. The electron doesn't have a precise position and momentum before measurement. Those properties don't exist as definite values. Measurement doesn't disturb pre-existing values. It forces values into existence where none existed before. Think about what that means. You fire an electron toward the slits. Before it arrives, it has no definite path. It's not taking path A or path B. It's in superposition of both paths. Then it hits the screen. Suddenly it has a definite position. One spot lights up. The superposition collapses. The electron that was everywhere becomes somewhere. But if you put detectors at the slits, you force the electron to have a definite path earlier. The moment the detector registers which slit, the superposition collapses right there. Now the electron has a path. It went through one slit. And electrons with definite paths don't interfere. They pile up like bullets, not like waves. The universe has this bizarre property where certain pairs of things cannot both be definite simultaneously. Position and momentum, energy and time, they're linked. Making one precise makes the other fuzzy. This isn't a limitation of knowledge. It's a limitation of reality itself. Now, I told you earlier I developed quantum electrodynamics, the mathematics of how light and matter interact. The theory works absurdly well. We've tested predictions to 10 decimal places, the anomalous magnetic moment of the electron, the Lamb shift in hydrogen energy levels. Calculated values match measured values so precisely it's almost unsettling. This isn't approximate science. This is exact. But here's what bothers me about my own theory. I can calculate anything you want. Give me an initial condition and a question. I'll give you a number. That number will match what you measure in the lab to ridiculous precision. But I cannot tell you what's actually happening between emission and detection. The mathematics works. The predictions are perfect. The physical picture makes no sense. We use things called Feynman diagrams, little pictures of particles exchanging photons, electrons emitting virtual particles, interactions happening. They're useful for organizing calculations. But are they real? Is the electron actually doing what the diagram shows? I don't know. Nobody knows. The diagrams are calculation tools that happen to work. Whether they represent physical reality is an entirely different question. And that's the honest truth about quantum mechanics. It's a computational framework that predicts experimental results with perfect accuracy, but it doesn't give you an intuitive picture of what's really going on. You cannot visualize it. You cannot draw it. You cannot build a mental model that makes sense. You just have to accept that nature operates this way. Particles in superposition until measured. Uncertainty built into the fabric of reality itself. Waves interfere. Particles don't. An electron does, both depending on whether you're watching. That's not a metaphor. That's what actually happens in laboratories every single day. I once said quantum mechanics describes nature as absurd from the point of view of common sense, and it does. Yet it fully agrees with experiment. Every prediction we make, no matter how strange, matches what we measure. The theory is correct, verified beyond any reasonable doubt, but I don't understand it. Nobody does. Let me be very precise about what I mean by that. I can solve the equations. I can calculate probabilities. I can predict what you'll measure before you measure it. That's understanding in the practical sense. But in terms of having a mental picture, a way of visualizing what's really happening, I have nothing. The mathematics works perfectly. The physical intuition is completely absent. People ask me to explain quantum mechanics in simple terms. They want an analogy, something familiar they can hold on to. But there isn't one. Things on a very small scale behave like nothing you have any direct experience with, not like waves, not like particles, not like anything you've ever seen. If I say electrons behave like particles, I give the wrong impression. If I say they behave like waves, equally wrong. They behave in their own inimitable way, a quantum mechanical way. You want to understand it? Stop trying to picture it. Stop asking how it can be like that. You'll drive yourself into a blind alley from which nobody has escaped. Instead, accept that nature behaves this way. Maybe she does. And if you can simply admit that possibility, you'll find her delightful, entrancing even. The implications go far beyond just understanding electrons. Every electronic device you use depends on quantum mechanics. The transistor in your computer, the laser reading data from a disk, LED lights, solar panels, medical imaging machines, GPS satellites correcting for quantum effects. We've built an entire technological civilization on principles we cannot visualize or intuitively grasp. We can use them. We cannot picture them. And here's what really bothers people. Classical physics gave us a clockwork universe. If you knew the initial conditions precisely enough, you could predict everything. The future was determined. Quantum mechanics destroyed that worldview completely. The uncertainty isn't in our knowledge. It's built into reality itself. The future is genuinely unpredictable in principle, not just in practice. Does this mean reality doesn't exist until we observe it? That's a horrible viewpoint. Do you seriously entertain the idea that without observers, there's no reality? I find that absurd. Yet the mathematics of quantum mechanics seems to require measurement to collapse superposition into definite outcomes. What counts as a measurement? Does it require consciousness, a detector, any interaction with the environment? We don't know. This is called the measurement problem. It's been around for nearly a century. We still don't have a satisfactory answer. Different interpretations have been proposed. The Copenhagen interpretation says particles don't have definite properties until measured. The many worlds interpretation suggests all possible outcomes actually happen in branching universes. Pilot wave theory proposes particles have definite positions guided by quantum waves. But these are interpretations, not testable predictions. No experiment can distinguish between them. They all make identical predictions. The choice between them is philosophical, not scientific. What I can tell you with certainty is this. Quantum mechanics is the most precisely tested theory in the history of science. We've measured certain quantities to 10 decimal places. The predictions match exactly. This isn't approximate. This isn't close enough. This is perfect agreement between theory and experiment. And yet the theory describes something fundamentally incomprehensible to human intuition. Nature operates according to quantum rules whether we like it or not, whether we understand it or not. The double-slit experiment with single electrons has now been performed exactly as I described it in my lectures. Every bizarre prediction confirmed. Each electron creates an interference pattern over time. Each one somehow knows whether both slits are open, trying to detect which slit destroys the pattern. Reality behaves exactly as the mathematics predicts, no matter how absurd that behavior seems. So when someone asks me why quantum mechanics works the way it does, I have no answer. I can describe how it works with extraordinary precision. I can calculate anything you want, but I cannot tell you why nature chose these rules instead of something sensible. Maybe there is no why. Maybe this is just what the universe is at its deepest level, a place where our intuitions fail completely, where mathematics works but visualization doesn't, where we can predict without understanding. That's quantum mechanics, not comfort, not intuition, not pictures you can draw or stories you can tell, just mathematics that matches reality to absurd precision, and the honest admission that despite creating the theory, despite using it successfully for decades, I still don't understand what's really happening. Nature is absurd, and nature is correct. That's what I meant when I called nature absurd, not broken, not mysterious in a way we'll eventually solve. Absurd, because the universe at its foundation operates by rules that make perfect mathematical sense and zero intuitive sense. We can calculate everything. We understand nothing. You wanted an explanation that would make you comfortable, something that would let you picture what's really happening when an electron goes through two slits. I cannot give you that. Nobody can. Not because we're bad at explaining, because there's nothing familiar to compare it to. What I can give you is this. The equations work. The predictions match reality to 10 decimal places. We've built computers, lasers, medical devices, an entire technological civilization on quantum mechanics. It's the most successful theory in the history of science. And I don't understand it. None of us do. We use it. We don't comprehend it. Maybe that's the deepest lesson. Nature doesn't owe us an intuition that works. She doesn't owe us pictures we can draw or stories we can tell ourselves. She just is what she is. Our job isn't to make her comfortable. It's to describe her accurately. And if that description is absurd from the point of view of common sense, well, maybe common sense is the problem, not nature.